Good morning, students. Let's start with a few of the problems of inverse trigonometric functions. Here I have written some of the 10 questions which I am going to solve it now. So first 6 questions is from LHS to RHS, we have to prove it, and the 7th and 8th question we have to evaluate and get its value. Question number 9, and it is also for evaluation. Question number 10, it is for prove that. So let us start with the first question. LHS, tan inverse of A by B minus tan inverse of A minus B upon A plus B. Here we apply the formula for tan inverse of x minus tan inverse of y. So tan inverse of A by B minus A minus B upon A plus B divided by 1 plus A by B into A minus B upon A plus B. Now, as we know, the formula for this is tan inverse of x minus tan inverse of y equals to tan inverse of x minus y upon 1 plus xy. So, tan inverse LCM B into A plus B. So here we get A into A plus B minus B into A minus B into, we take the reciprocal, B into A plus B upon B into A plus B plus A into A minus B. So B into A plus B, B into A plus B will be cancelled out. Now tan inverse of A square plus AB minus AB plus B square upon AB plus B square plus A square minus AB plus AB cancel out. Here also minus AB plus AB cancel out. We get tan inverse of A square plus B square upon A square plus B square. This cancel out. We get tan inverse of 1, that will be pi by 4. As tan pi by 4 45 degree value is 1, so tan inverse 1 here it is written as equals to pi by 4, and that is our RHS. So this is our first question. Now let's move to the second question. Second question is given LHS sine inverse of 1 by root 5 plus sine inverse of 1 by root 10. As we know that sine inverse of x plus sine inverse of y is equals to sine inverse of x into under root 1 minus y square plus y into under root 1 minus x square. That is our formula. Now, in place of x we put 1 by root 5, in place of y we substitute 1 by root 10. So, sine inverse of 1 by root 5 plus sine inverse of 1 by root 10 equals to sine inverse of x 1 by root 5 under root 1 minus y square. 1 by root 10 the whole square will become 1 by 10 plus y 1 by root 10 under root 1 minus x square. 1 by root 5 the whole square will become 1 by 5. So equals to sine inverse of 1 by root 5 into 10 minus 1 9. So square root of 9 is 3 and root 10 plus 1 by root 10 and 5 minus 1 4. Square root of 4 will be 2 by root 5. That becomes sine inverse of 3 plus 2, 5 upon root 50. That becomes sine inverse of 5 root 50. Simplest form can be written as 5 root 2, 5 and 5 cancel, and sine inverse of 1 by root 2, which is equals to pi by 4. As we know that sine 45 degree is 1 by root 2. So that is the RHS for our second question. Now let's move to our third question. For question number 3, LHS sine inverse of 4 by 5 plus sine inverse of 5 by 13. As here we can see in the LHS, both the functions are sine inverse x plus sine inverse y. We can apply sine inverse x plus sine inverse y formula, and at last we will change the sine inverse function to the cos inverse. Otherwise we can apply another method also. Let sine inverse of 4 by 5 is equals to, we take it as alpha. So what we get, sine alpha is equals to 4 by 5. Now we calculate for the value for cos alpha, which is under root 1 minus sine square alpha. So under root 1 minus 16 by 25 under root 9 by 25, that is 3 by 5. Now, and we assume that sine inverse of 5 by 13 is equals to beta, which implies that sine beta will be equals to 5 by 13. So cos beta will become under root over 1 minus of sine square beta equals to under root over 1 minus of 25 by 169, which is equals to 144 by 169, that is 12 by 13. So as it is given sine inverse, we take it as equal to alpha. We get the value of sine alpha by using the identity. We can calculate the value for cos alpha. In the same way, second one also, we take it as equal to some other value beta, and we get the value for sine beta. We can calculate with the help of the identity cos beta's value 12 by 13. As in the RHS, we have to prove cos function. So we will take it as here cos alpha plus beta, since we know that cos alpha plus beta. As here in these two trigonometrical function LHS, there is a additional sign, plus sign. So we have to take the formula for alpha plus cos, alpha plus beta. We are taking cos because right side we have to show for cos, and we are taking plus because left side both the trigonometrical functions are in the plus additional case. So cos alpha plus beta formula, cos alpha cos beta minus sine alpha sine beta. And now substitute the value. Cos alpha is given to us 3 by 5. Cos beta is calculated 12 by 30. Sine alpha is 4 by 5. Sine beta is 5 by 13. So that is 36 upon 65 minus 20 upon 65, which is equals to 16 upon 65. Now cos alpha plus beta is equal to 16 upon 65. So we can convert in the inverse form. Alpha plus beta will become equal to cos inverse of 16 by 65. Now alpha and beta. Alpha is our sine inverse of 4 by 5 and beta is our sine inverse of 5 by 13. So we can put the values here. Sine inverse of 4 by 5 plus cos sine inverse of 5 by 13 is equals to cos inverse of 16 by 65. So this is also the another way of proof. You can apply any method, but you have to prove it correctly step by step. So once again we can apply, we will see this method. Sine inverse of 4 by 5 alpha, sine alpha 4 by 5. We have to calculate the value for cos alpha, and then sine inverse of 5 by 13 we take beta, sine beta 5 by 13, and we have to calculate for cos beta, that's 12 by 13. As the RHS is we have to prove for cos, so we have taken cos, and here it is a plus. So we have taken cos alpha plus beta. Our 11th class formula cos alpha plus beta equals to cos alpha cos beta minus sin alpha sin beta. After substituting the value, we got 16 by 65. So alpha plus beta equals to cos inverse of 16 by 65. At last, alpha and beta is equal to sin inverse of 4 by 5 plus sin inverse of 5 by 13. We are replaced here respectively. That is our proof. Now let's move to the question number 4, that is cot inverse of 3 plus cosec inverse of root 5. Now Here there are two different trigonometrical identities, so we can apply the formula. Cot inverse of 3, here it is cosec inverse, and we have to show pi by 4. So cot inverse can be converted to by using a reciprocal property, tan inverse of 1 by 3, and cosec inverse of root 5 we have to convert in the form of a tan inverse by applying the conversion property. You just draw a triangle, and cosec theta is hypotenuse by perpendicular root 5 by 1. When we apply the Pythagoras theorem, hypotenuse square 5 minus base minus perpendicular square equals to 4, and we get the value square root of it is 2. So hypotenuse square root 5 square 5 minus perpendicular square 1 square, that is 5 minus 1 4, square root of 4, that we get as 2 as a base. So now we can convert in the form of tan. So tan formula is perpendicular by base, so this becomes 1 by 2, tan inverse of 1 by 2. So now we can apply the formula tan inverse of x plus tan inverse of y, that is tan inverse of x plus y upon 1 minus x into y. Tan inverse of, after taking LCM, 3 plus 2 upon 6 into 6 upon 6 minus 1. 6 and 6 cancels. So tan inverse of 5 upon 5, that cancels out. Tan inverse of 1, which is equals to pi by 4, that is our RHS. Now let's move to the question number 5. Now question number 5, LHS, tan inverse of 1 by 2 plus tan inverse of 1 by 3 plus sine inverse of 1 by root 5 plus cot inverse of 3, which is equals to pi by 2. Here we can apply the formula tan inverse of x plus tan inverse of y. This we will convert to tan inverse by using the conversion property, and this cot inverse we can convert to the tan inverse by using the reciprocal property. So tan inverse of 1 by 2 plus 1 by 3 upon 1 minus 1 by 2 into 1 by 3. That is tan inverse of x plus y upon 1 minus xy plus, just now we have converted sine inverse perpendicular by hypotenuse, Pythagoras theorem using the calculate base 2, and we can convert in the form of tan inverse of 1 by 3, and plus this becomes tan inverse of 1 by 3. So this tan inverse of 5 by 6 upon 5 by 6 plus tan inverse of, again we can apply here x plus y, 1 by 2 plus 1 by 3 upon 1 minus 1 by 2 into 1 by 3. This becomes tan inverse of 1 plus tan inverse of, here also we get 5 by 6 upon 5 by 6, which becomes 1. So tan inverse of 1 pi by 4, which further gets pi by 2 as the RHS. Now let's move to the question number 6. Question number 6 is the most important question. LHS sec square tan inverse of 2 plus cosec square cot inverse of 3. As we know that sec square, this we are considering as a theta, and this we are considering as an alpha. If sec square theta, from the 10th class we studied the identity, sec square theta is equals to 1 plus tan square theta. So this can be written as 1 plus tan square tan inverse of 2, and cosec square theta can be written as 1 plus cot square theta. So 1 plus cot square cot inverse of 3. Since 1 plus tan square theta is equals to sec square theta, and 1 plus cot square theta is equals to cosec square theta. So 1 plus tan inverse of 2, the whole square, we can write down tan square theta, tan theta the whole square, plus 1 plus cot inverse of 3 the whole square. By using the self-adjusting property, as we know that tan inverse of x is equals to x, but in place of x here it is 2. So tan inverse of 2 will become 2 whole square plus 1 plus cot inverse of 3 by self-adjusting property 3 square 1 plus 4 plus 1 plus 9 which is equals to 15. That is our RHS of the 6th question. Now we move to the 7th question. 7th question is evaluate sine 2 sine inverse of 0.6. Since we know that 2 sine inverse of x, this 2 sine inverse of x is given by the formula sine inverse of 2x into under root 1 minus x square. So this what we writing sine 2 sine inverse x, sine inverse 2x 2 into 0.6 into 1 minus 0.6 the whole square. So this becomes sine inverse of 2 into 6 by 10 into under root over 1 minus 36 by 100. That is sine inverse of 2 into 6 by 10 into 100 minus 36, 64 square root 8 and square root of 100 10. So sine inverse 2 into 6 12 into 8 96 by 100. So sine inverse 0.96 which becomes by self-adjusting property sine inverse of x will be x, so it will become 0.96 our answer. So that is the evaluation. 2 sine inverse x is given by sine inverse 2x into under 1 minus x square. The value of x is our 0.6, so we substituted and remove the decimal 6 by 10. This becomes 6 by 10 the whole square 36 by 100. After calculation we get 8 by 10 and we simplified and we at final answer we got it 0.96. Let's move to the question number 8. Now question number 8, evaluate sine pi by 2 minus sine inverse of minus of root 3 by 2. So sine pi by 2 plus sine inverse of root 3 by 2. As we know that sine inverse of minus of x is minus of sine inverse of x. So it becomes plus. Now sine pi by 2 plus sine inverse of root 3 by 2. Sine 60 degree is root 3 by 2. 60 degree stands for pi by 3. So this we can write as pi by 3. So sine it becomes 5 pi by 6. And sine 180 minus theta is sine theta. So we can write down as sine pi minus pi by 6. Sine 180 minus theta, sine theta, so it becomes sine pi by 6, sine 30 degree. That is 1 by 2 is our answer. Now let us move to the question number 9. Cos inverse of 1 by root 10 is equals to a. So cos a will be equals to 1 by root 10 which is base by hypotenuse. So we just draw one triangle, right angle triangle, acute angle A, B, C, base by hypotenuse by Pythagoras theorem. By Pythagoras theorem, we have AB square, base square plus perpendicular square equals to hypotenuse square. AB 1 plus BC square equals to root 10 the whole square. 1 plus BC equals to 10. BC square equals to 9. BC is equals to 3. So this we get the perpendicular as 3. And now what we have to calculate? We have to calculate tan A and cos A. As we know that the tan is given by perpendicular by base. So acute angle is A. So perpendicular 3, base is 1. So 3 by 1. And now we have to calculate for cosec A. Cosec is hypotenuse by perpendicular. So hypotenuse is root 10 and perpendicular is 3. So that becomes root 10 by 3. So if cos inverse of root 10 equals to A, we can get cos A equals to 1 by root 10, which is base by hypotenuse. And we can calculate by using the Pythagoras theorem the perpendicular of it. And then after getting all the three sides of the rectangle triangle, we can calculate the value tan A perpendicular by base and cosec A hypotenuse by perpendicular. So that is our final answer for tan A and cosec A. Now let's come to the question number 10. Question number 10, LHS cos inverse of 4 by 5 plus cos inverse of 12 by 13. As we know that cos inverse of x plus cos inverse of y is equals to cos inverse of xy minus under root 1 minus x square into 1 minus y square. This is our formula. So now cos inverse of xy 4 by 5 into 12 by 13 minus under root over 1 minus 16 by 25 into under root over 1 minus 144 by 169. So cos inverse of 12 into 4 48 upon 65 minus 25 minus 69 3 by 5, and this will become 169 minus 144 25 5 by 13. So cos inverse of 48 minus 15 upon 65, that becomes cos inverse of 33 by 65, that is our RHS. So these are the 10 questions. In the same way you have to solve the rest of the questions from any of the NCERT textbook or from the refresher. The same type of proof, that questions, evaluation questions, all these questions you have to practice from the other textbook. Now let's come to the next variety of questions, that is restricted trigonometrical, inverse trigonometrical identities. Restricted trigonometrical identities, that is condition is given, you have to prove it. Condition is given, you have to prove it. The conditions will be given and you have to prove the given relation. That is, if tan inverse of x plus tan inverse of y plus tan inverse of z equals to pi by 2. So what we do, any one of the trigonometrical term we can shift to the RHS pi by 2 minus tan inverse of z. So tan inverse of x plus tan inverse of y equals to pi by 2 minus tan inverse z is cot inverse of z. As we know that tan inverse of x plus cot inverse of x is equals to pi by 2. So tan inverse of x plus y upon 1 minus xy equals to tan inverse of 1 by z. This we are using the formula tan inverse of x plus tan inverse of y, and right side we are applying the reciprocal property. Now both the left and right side there is a single trigonometrical term tan inverse. So we are now going to compare their angles. Not we are going to cancel out tan inverse x. So therefore x plus y upon 1 minus xy equals to 1 by z. Cross multiply xz plus yz equals to 1 minus xy. Transpose it, xy plus yz plus zx will be equals to 1. So that is our proof. The next one is given, second question, if tan inverse x plus tan inverse z plus tan inverse y is equals to pi, here also what we do, tan inverse of x plus tan inverse of y is equals to pi minus of tan inverse of z. So tan inverse of, again formula, x plus y upon 1 minus xy, and this becomes tan inverse of minus z. As we know that in class 7 tan 180 minus theta is minus tan theta. So here 180 minus tan inverse of z will be tan inverse of minus z. So now again we are going to compare their angles. X plus y upon 1 minus xy equals to minus z. So what we get? X plus y is equals to minus z plus xyz. So just we transpose it. X plus y plus z is equals to xyz. So that is our proof. This is the proof. Now let's move to our third question. Cos inverse of x plus cos inverse of y plus cos inverse of z is equals to pi. So cos inverse of x plus cos inverse of y is equals to pi minus of cos inverse of z. Formula cos inverse xy minus under root 1 minus x square under root 1 minus y square. Cos 180 minus theta is minus cos theta. So pi minus cos inverse of z will be cos inverse of minus z. Now again there is a single terms of cos inverse, both the left and right side they can compare their angles. Xy minus under root 1 minus x square 1 minus y square equals to minus z. As now there is the non-radical and radical terms. So radical terms we have to put it at one side only. So what we do, we just transpose xy plus z equals to under root 1 minus x square into 1 minus y square. Now we square both the sides. On squaring both the sides, we have xy plus z the whole square equals to under root 1 minus x square 1 minus y square the whole square. So x square y square plus z square plus 2xyz, that is 1 minus x square into 1 minus y square. So x square y square plus z square plus 2xyz equals to 1 minus y square minus x square plus x square y square. So similar terms will be cancelled out, and now we just transpose this x square and y square towards the left. X square plus y square plus z square plus 2xyz is equals to 1. So that is our proof. So this proof we got it. Now let's move to our next question, that is the question number 4. Question number 4. Cos inverse of x by 2 plus cos inverse of y by 3 equals to theta. We apply the formula cos inverse of x plus cos inverse of y, x by 2 into y by 3 minus under root over 1 minus x square by 4 under root 1 minus y square by 9 equals to theta. So cos inverse of xy by 6 minus under root over 4 minus x square under root over 9 minus y square divided by 6 is equals to theta. Square root of 4 will become 2, square root of 9 will become 3, 2 into 3, 6. Now xy minus under root 4 minus x square under root 9 minus y square, and this cos inverse we can take to here cos theta, and this 6 we can cross multiply 6 cos theta. Now just radical terms we are going to put at one side. Xy minus 6 cos theta is equals to under root over 4 minus x square into 9 minus y square. On squaring both the sides, on squaring both the sides, we have xy minus 6 cos theta the whole square under root over 4 minus x square under root 9 minus y square the whole square, x square y square plus 36 cos square theta minus 12xy cos theta 4 minus x square into 9 minus y square. So x square y square plus 36 cos square theta minus 12xy cos theta equals to 36 minus 4y square plus 9x square, sorry, minus 9x square plus x square y square, the like term will cancel out. Now this minus 9x square and y square transpose towards the left, we get 9x square plus 4y square minus 12xy cos theta, which is 36 minus, this we transpose towards the right, 36 cos square theta. So 9x square plus 4y square minus 12xy cos theta, 36 common, 1 minus cos square theta, and 1 minus cos square theta is sin square theta, which becomes now 36 sin square theta. So we get the proof, this one 9x square plus 4y square minus 12xy cos theta equals to 36 sin square theta. Now let's come to the fifth question. The fifth question is that if since sin inverse of x plus sin inverse of y plus sin inverse of z is equals to pi. So let sin inverse of x is equals to capital A, which implies sin A will be equals to x, and which implies cos A will equals to under root over 1 minus sin square A, that will become under root 1 minus x square. In the same way, sin inverse y equals to b implies sin b equals to y, implies cos b will be equals to under root over 1 minus y square. The last one, sin inverse z equals to c implies sin c will be equals to z, implies cos c will be equals to under root over 1 minus z square. As we have taken sin inverse x a, sin inverse y b, sin inverse z c, so this equation one which is given to us will now become a plus b plus c is equals to pi in any triangle. So now the LHS of our proof, x into under root 1 minus x square plus y into under root 1 minus y square plus z into under root 1 minus z square. X is our sin A, under root 1 minus x square is cos A, sin B, cos B, z is sin C, and this is cos C. Now we are going to multiply and divide each term with 2. So we get 2 sin A cos A to make the formula of sin 2A, 2 sin B cos B to make the formula for sin 2B, 2 sin C cos C to make the formula of sin 2C. That is 1 by 2A, 1 by 2 sin 2A, sin 2 theta, sin 2B, sin 2 theta, sin 2C, sin 2 theta, as sin 2 theta is 2 sin theta cos theta. Now sin x plus sin y, in class 11 we have studied the formula 1 by 2 sin x plus y by 2, 2a plus 2b by 2 cos 2a minus 2b by 2 plus sin 2 sin c cos c. Now 1 by 2 sin a plus b cos a minus b plus 2 sin c cos c. This 2 we can take common, 2 by 2 sin a plus b. A plus b can be converted from this equation number 2 as pi minus c. So it becomes pi minus c cos a minus b plus sin c cos c. And next 2 cancel out. sin 180 minus theta sin C cos A minus B plus sin C cos C. Now I can take common sin C from here. So sin C is taken common, cos A minus B. Now plus this cos C, angle C की value pi minus of A plus B. So cos pi minus of A plus B. So it becomes sin C cos A minus B. Cos 180 minus theta is minus cos theta minus of cos A plus B. So what we have, previous year class 7 we have studied cos A minus B minus cos A plus B is equals to 2 sin A sin B. So we get sin C into 2 sin A sin B. So we get 2 sin A की वैल्यू है x, sin B की वैल्यू है y, sin C की वैल्यू है z. तो ये हो जाएगा 2xyz, that is our RHS. So once again you can listen, we can take sin inverse of x equals to A, it becomes sin A equals to x. So cos A under root 1 minus sin square x, so it will become 1 minus x square. In the same way, sin inverse y equals to B, sin B equals to y, so cos B under root 1 minus y square. Sin inverse z equal to C, sin C equals to z, so cos C equals to under root 1 minus z square. As in the proof, our LHS is given x under root 1 minus x square plus y under root 1 minus y square plus z under root 1 minus z square. So it becomes x की वैल्यू क्या है sin A और अंडर रूट 1 माइनस x स्क्वायर की वैल्यू क्या है cos A. इसी प्रकार से sin B cos B sin C cos C. फॉर्मूला में कन्वर्ट करने के लिए 2 से मल्टीप्लाई और डिवाइड किया गया है. तो 2 sin A cos A का फॉर्मूला होगा sin 2A, 2 sin B cos B का फॉर्मूला होगा sin 2B, 2 sin C cos C का फॉर्मूला होगा sin 2C. और क्लास 11th में सेम क्वेश्चन अपन पढ़ चुके हैं पहले भी, इसलिए सेम उसी टाइप का ही प्रूफ है. sin x plus sin y is given by 2 sin x plus y by 2 into cos x minus y by 2. So we applied this formula and sin 2 theta 2 sin theta cos theta. Now this becomes 2 sin A plus B cos A minus B. A plus B can be converted from this equation in the form of pi minus C. So we can replace the value of A plus B here as pi minus C. Rest is same. And cos 180 minus theta is cos sin theta. Sin 180 minus theta is sin theta. So sin C we can take common. Cos A minus B plus cos C. This C we can take out the value of C from here. Pi minus of A plus B. So pi minus of A plus B. As we know that cos 180 minus theta is minus cos theta. So it becomes minus of cos A plus B. And we know the formula. Cos A minus B minus cos A plus B is 2 sin A sin B. So it becomes 2 sin A sin B sin C, and that is equals to 2xyz RHS.